Good day, everyone. How are you today? I hope everyone is in good condition. For this day, our topic is all about volcanoes, earthquakes, and mountain ranges. The most essential learning competency that will be tackled is describe and relate the distribution of active volcanoes, earthquake epicenters, and major mountain belts to plate tectonic theory. I am your science teacher, Sir Roy M. Kaput. The following are the learning objectives for this particular lesson. First, describe and relate the distribution of active volcanoes, earthquake epicenters, and mountain belt to plate tectonic theory. Second, recall the different layers of the Earth. Third, explain the plate tectonic theory. Fourth, familiarize with the anatomy of earthquake and other related terms. And the last one is to describe how volcanoes and mountains are formed. To start with, let us first have unlocking of difficulties. Let us have the definition of the different scientific concepts that we're going to tackle with our lesson. Let's start with active volcano. A volcano with account of eruption documented within 10,000 years. Continent. A big body of land on the globe. Earthquake. A vibration of Earth due to rapid release of energy. Epicenter. The location on the Earth's surface directly above the focus of an earthquake. Focus. The exact site of the origin of an earthquake. It is below the epicenter. Magma. The liquid rock below the Earth's surface. Mountain. A landmass that projects well above its surrounding. It is higher than a hill. Mountain range. A chain of mountains. Seismic waves. Earthquake waves. Primary wave. The first type of seismic wave to be recorded in seismic station. These compression waves are the fastest and travel through solid, liquid, and gases. Secondary wave. The second type of earthquake wave to be recorded in a seismic station. These shearing waves are stronger than the P wave, but only move through the solids. Seismogram. The graphical record of an earthquake. Seismograph. A measuring instrument for detecting and measuring the intensity and direction and duration of movements of an earthquake. Tsunami. Japanese term for big wave in the port generated during undersea quakes. Volcano. A mountain or hill typically conical having a crater or vent through which lava, rock fragments, hot vapor, and gas is being or have been erupted from the Earth's crust. Now let us proceed with our main topic, which is volcanoes, earthquake, and mountain ranges. As you can see in the illustration, it shows the layers of the Earth. If we're going to recall, this includes the crust, which is the outermost layer, the mantle, the second layer, which is considered to be the thickest one. We have the outer core, or the liquid core, and we have here the inner core, or what we call as the solid core. Let us discuss them one by one. Let us first elaborate the concept of crust. As you can see in the illustration, the crust has two major types. These are the continental crust and the oceanic crust. When we speak of the continental crust, it pertains to the land bodies, usually 30-kilometer thick, and the type of rock that consists the continental crust are the granite rocks. On the other hand, the oceanic crust can be found in the bottom of water bodies, which is estimately 5 to 8 kilometer thick. These are composed of the basalt rocks. And did you know that the transition zone between these two types of crust is sometimes called the Conrad discontinuity? Let's have the mantle. Okay, as you can see in the illustration, the mantle is the thickest layer of the Earth. And in the mantle, we can find the asthenosphere. The asthenosphere is the ductile part of the Earth just below the lithosphere, including the upper mantle. A zone of Earth's mantle lying beneath the lithosphere and believed to be much hotter and more fluid than the lithosphere. So meaning to say, the asthenosphere is a fluid-like, okay, fluid-like layer in the mantle. It is where the plates or the tectonic plates float. The next part is what we called as the core. Okay, look at the illustration. The one that the arrow points is our core. It is consists of the outer core and the inner core. The outer core is liquid, about 1,300 miles thick. It is primarily consists of the iron and nickel. On the other hand, the inner core is said to be solid, about 1,500 miles thick. Okay? And it is solid because it is under intense pressure, which keeps it solid despite high temperature. Now that we are already familiar with the different layers of the Earth, let's now talk about the lithosphere. When speak of the lithosphere, okay, this is composed of the crust and the upper mantle. The lithosphere is said to be in constant but very slow motion. This means that it has motions which are not the same everywhere. This movement of the lithosphere is called to be tectonics. When you're going to look at this particular illustration, we can see that the lithosphere is divided into huge slabs called the tectonic plates. It is said that the heat from the mantle makes the rocks at the bottom of the lithosphere slightly elastic, which allows the plates to move. Let's talk about the plate tectonic theory. According to this theory, the entire lithosphere of the Earth is broken into numerous segments called the plates. Okay? So remember that the lithosphere is broken down into pieces, and that is what we call as the plate or the tectonic plates. These plates move over the asthenosphere. Okay? So if we're going to recall, asthenosphere is the partially molten part of the mantle, the molten upper portion of the mantle. And by looking at the illustration, we can see here that there are movements that happens in the plate boundaries, okay, or in the edges of the tectonic plates. Could either be in the subduction or lateral sliding, or it can also be in the form of spreading. So these are the people or the scientists who contributed to the plate tectonic theory. The first one is Alfred Wegener. Okay, he's the one who popularized or the theory of continental drift theory. So once there was a large or supercontinent known as the Pangaea, and as time passes by this Pangaea, okay, the supercontinent divides into pieces or move away from each other. It was supported, okay, by Harry Hess in his theory of seafloor spreading. Since plates are in constant motion, mean to say the plates are moving slowly as they interact along their margins. When speak of the margins, we are referring to the boundaries or the edges of the plates. Important geologic processes takes place. Okay, meaning to say every time that the plates are moving, okay, so there is something that is being formed. or something that occurs. It could either be in the form of an earthquake, okay, or the shaking of the ground, in the form of mountains, okay, a land feature which is higher than the hill, and can also be resulted into formation of volcanoes, okay, or mountains that possess craters. Let us first talk about the earthquake. So earthquake refers to vibration of earth due to the rapid release of energy. Earthquake waves are known as the seismic waves. Now, seismic wave can be categorized into two: the body waves and the surface waves. The body waves, it can travel through the Earth's inner layers. Okay? So those are the mantle and the core. On the other hand, as well as the crust. On the other hand, the surface waves, it can only move along the surface of the planet, like ripples on the water. When speak of the ripples, these are small waves, okay, in the water. Next one is the body wave. So by looking at the illustration, we have here two types. The primary wave or the P waves are compression waves. Okay? They can propagate in solid or liquid material. From the word itself, compression, it compressed. There is a compression part in the wave. Okay? And the second one is secondary waves, or also known as the S wave. These are shear waves. They only propagate in solid material. So, as you can see in illustration, okay, it creates a wave-like motion as it travels through the solid. So, these are the different vocabulary terms which are related to earthquake. Let us familiarize ourselves. First one is seismology. It is the scientific study of earthquakes and related phenomena such as volcanic eruptions. Second, seismologists are scientists who studies earthquake and their waves to figure out the Earth's structure and composition. Next is seismographs. These are instruments used to record the motion of the ground during an earthquake. The last one is a seismogram. It is the recording of the ground shaking at the specific location of the instrument. We also have the term known as tsunami. Okay? Tsunami, it is a series of waves in a water body caused by the displacement of a large volume of water, generally in an ocean or a large lake. Mean to say there is a shaking of the ground just below, okay, the body of water, which causes the water waves to rise. We also have here the concept of volcanoes. Okay? A volcano is an opening in the Earth's crust through which lava, volcanic ash, and gases escape. If we're going to recall, there are different parts of the volcano, like the magma chamber, okay? That is the container of the magma. We also have here the vents. The vents are the channel where the magma, okay, flows throughout the volcano. And we have here the crater or the opening or the mouth of the volcano. So there are some cases wherein the magma flows out of the volcano in other hole, and that is what we call as the secondary vent. On the land, volcanoes form when one tectonic plates move under another. Usually, a heavy oceanic plate subducts, okay, or moves under a thicker continental plate. When this happens, the ocean plate sinks into the mantle. Let us discuss briefly the different classification of volcanoes. We have three: active, dormant or inactive, and we have the extinct. By looking at this illustration, we can easily identify the differences between these three classifications. If we're going to look at the active volcano, we can see that the magma chamber, okay, possess enough amount of magma for it to be triggered to erupt. Okay? On the other hand, when we talk about the dormant or the inactive volcano, although there is no record of eruption within the 10,000 years ago, still we can say that there is a tendency that this particular type of volcano erupt in the future because of the existence of magma in the magma chamber. On the other hand, when speak of the extinct volcano, since we can see that there is no existence of magma in the magma chamber, therefore, this particular type of volcano has no tendency, okay, to erupt in the future or in the present time. Now, what is the reason why the Philippines is usually visited by earthquakes? It is because we are located in the Pacific Ring of Fire. So here is the illustration of the Pacific Ring of Fire. It is a long chain of volcanoes and other tectonically active structures that surround the Pacific Ocean. The Ring of Fire is one of the most geologically active areas on Earth and a site for frequent earthquakes and powerful volcanic eruption. Okay, since this particular area is surrounded by volcanoes, okay, for every eruption it could trigger earthquake. So that's why areas which are found, okay, within the ring of fire is usually visited by earthquakes. Now, if we're going to look at the Philippine map, we can say that the Philippines belongs to the Pacific Ring of Fire, where the oceanic Philippine Plate and several smaller microplates are subducting along the Philippine Trench to the east, and Luzon, Sulu, and several other small trenches to the west. The tectonic setting of the Philippines is said to be complex. With that, here are the major volcanoes in the Philippines. For the record, there are about 300 volcanoes in the Philippines. 22 of these are considered to be active, while the larger percentage remains dormant as of the record. The majority of the active volcanoes are located in the island of Luzon. Here are the 6 most active volcanoes in the Philippines. We have Mount Mayon, Mount Hibok-Hibok, Mount Pinatubo, Mount Taal, Mount Canlaon, and Mount Bulusan. Here are some of the famous volcanoes in the Philippines. The first one is Mount Mayon, which is famous for its conical or perfect cone shape. We also have here Mount Taal, okay, an example of a crater lake, okay, which has erupted recently. And we also have here Mount Pinatubo, okay. It is characterized by its large crater known as caldera, okay. Mount Pinatubo has a record in the history because its eruption in 1981 decreases the global temperature by at least 1 degree Celsius because of the release of too much ashes in the atmosphere. Now, how about the mountain? A mountain is a landform that rises prominently above its surroundings. Example of a mountain in the Philippine setting is Mount Apo, located in the boundary of North Cotabato and Davao. How are we going to differentiate a mountain range from that of a mountain? A mountain range is a series of mountains ranged in a line and connected by high ground. Example of this is Sierra Madre Mountain Range, which is considered to be the longest mountain range in the Philippines. Question is, How are mountains formed? The world's tallest mountain ranges from form when pieces of Earth's crust, called the plates, smash against each other in a process called plate tectonics, and buckle up like the hood of a car in a head-on collision. There are some types of mountains depending upon on how they are formed. First one is the folded mountain. It is formed when continental plates collide. Second, upwarp mountain, formed when molten rock rises up and pushes layers of rock up. Next is fault block mountains, formed when block of rock drops down compared to the other blocks. And the last one is volcanic mountains, formed when magma spills and hardens on the Earth's crust. These are the different references that I made use for this presentation.